Okay, so I know that many of us have finished 3A, some with my help, some with not so much help. 3A is a really tricky one, and so I just wanted to share it with everybody. I've worked with some of you on this already, but just taking a look at it again probably isn't going to hurt. So let's take a look. In this case, a 350-mile trip. The automobile gets 30 miles per gallon and gas costs $3.17 per gallon. And we want to figure out what the total cost of the gas is for the entire trip. And there are a lot of correct, legitimate ways to manipulate these three numbers and get the right answer at the end of the day. I'm looking for one specific way to get the right answer at the end of the day. To me, it's not so much about the right answer, it's about the process. And I know that some tables are starting to rebel a little bit because they want to do this in a not Ian approved way. And I get that, but I just need you to trust me that I've got like a big plan, you know, like for the whole semester here, and this is part of it. And so we're going to push you to just outside of your comfort zone, and I think that's an okay thing. So we got to start with one of these numbers. Now the hint here says start with the 350-mile trip. I want to try to vocalize why it is we're starting with that as opposed to starting with 30 miles per gallon and $3.17 per gallon. The 350-mile trip is something specific to the person involved in this problem. Does he have a name? No. So the driver drove 350 miles, and if they drove 351 miles, it would be a different problem, right? The 350 is really the only thing that the person in this trip had any control over, as opposed to the 30 miles per gallon, which is basically like what the car gets, right? As opposed to the $3.17 per gallon, which is what we would all pay regardless of how far we were going. So for me, there's two numbers in this problem that are kind of just constants, the 30 and the 317, like available to the public. And then there's the 350-mile trip, which is the only choice that this person made. And so we're starting with the one thing that we had control over, the 350 miles. And so we'll start here, 350 miles. I know that in the baby example, it was all fractions. If you really want to have a fraction, it's 350 miles for the trip, okay? And then we're going to multiply by big blank fraction. And our job is to start canceling units. I don't like the fact that there are miles here, so I need to put miles either up or down. Where do I put it to cancel this is down, right? Because this one's up on the top. So we put it down here. Yes, Carrie? Yes. Yeah, and that's I think yeah, and so I think that's a good way to think of it. Ultimately, we want the costs, so we better end up with dollars on the top, not miles. So that's the motivation for getting rid of miles. Okay, so I've got miles down here. There are a lot of things that we can convert miles. For example, I could put feet. Don't write this, but I know how many feet there are in a mile, right? 5,280. I could put that, and it's completely legal. But feet isn't heading me where I want to go. So you need to really think carefully about where you want to go. Feet doesn't get me any closer to costs. Feet is still a distance. So we come up into the problem. We say, okay, I've got miles here. I see the word miles there. I see the word miles there. I've already used the 350, but I haven't used the 30 yet. And so that's what's got my attention. And in this next thing here, highlight the whole thing, it says 30 miles per gallon. So, oh, great. I can put gallons right up there. Miles per gallon. Where does the 30 go? Next to the gallons or next to the miles? It goes next to the miles. You got to be really clear. It is 30 miles per how many gallons? 1 gallon, right? It's implied. When we say per gallon, we mean per one single gallon. Okay, and then the nice thing about what we just did is that miles cancels. And we currently now have gallons per trip, which is heading us closer to cost per trip. Times. One more fraction. I don't like gallons, so where should we put it? On the bottom. I am looking for something else I can put up here that relates to gallons. There is one appearance of the word gallon in this problem. It says it costs $3.17 per gallon. So what are the corresponding units up here? Dollars. $3.17 or 317 gallons? $17. $3.17 gets you how many gallons? 1. And then again, the units cancel, gallons and gallons. And what are the units left on the top? Dollars, and on the bottom, trip. And that's what I want. How many dollars per trip? So then it's just a calculator, multiply across the top, 350 times 3.17 divided by 1 times 30 times 1. You get whatever you get. Anybody have the number already?
36.
Okay. So $36.98. Okay. So I mentioned at the start of today's class that the material today was possibly going to be tougher than the stuff that we've seen before. I wasn't lying to you. But again, part of my job is to push you slightly outside of your comfort zone. If I started talking like Calculus 3, that's not within the realm of like near enough to the comfort zone, but I'm pushing you slightly out of your comfort zone. I think that's a good thing. Okay, so I know that most of my groups, yeah, Carrie? Go ahead. Mm-hmm. Too low or too high? Yeah, so let's think about it. 30 miles for every gallon, right? Roughly how many gallons are we using here? Just ballpark. 30 miles per gallon, and it's 350-mile trip. It's about 12. There's a little bit more than 10, right? 10 gallons will get you 300 miles. Yeah? So it's about 12 gallons of gas. Okay, so I'm paying 12 of those. Yeah. Yeah, back when this problem was written a few years ago, gas was around 317. It's got a lot less. You're welcome. Okay, yeah, always a good idea to just kind of check against reality. Okay, so what we are going to do is spend our last 12-ish minutes taking a look at slope. So can everybody jump to this page right here, page 36? Okay, so here's the plan. We are going to introduce slope here. I think it's something that all or most of you have seen before, so hopefully this will be kind of a review, and we'll bring back some stuff you already know about that word slope. I don't think we're quite going to finish the demo, but the demo here is a lot shorter than the demo from the first topic for today. So we'll get as far as we get, and then we'll pick up right there on Tuesday, continuing slope. Slope homework is not assigned for over the weekend.
Okay,
Yes.
I was just going to ask that. So we don't have to finish the packet for the activity 5?
Correct. So yeah, so anytime I get you to start one of the activities in class, it probably means I'm expecting you to finish them outside if you haven't finished them yet. But let's just take our look at this calendar so we can really be sure how we're reading it. Today it says here, February 2nd, we're doing all of lesson 4 and we are starting lesson 5. What that means is that I want you to finish the activities for lesson 4. Most groups didn't quite get there today, but that's okay. It was tough stuff today. But this S means I'm going to give you a ton of time next class to finish, start and hopefully finish the activities for 5. Okay? So, yeah. Don't have to worry about 5 at all. I'd like you to finish 4 if possible. Good question. Yeah. Okay. Daily summary. In this lesson, we define the slope of a line, and we see several ways to calculate and use slope. A portion of road A climbs steadily for 120 feet over a horizontal distance of 4,250 feet. A portion of road B climbs steadily 95 feet over a horizontal of 2,875 feet. Which road is steeper? We're going to draw and label 2 diagrams to illustrate the situation. First one has been done already. Here is road A. I will just highlight in blue here. This is where the actual road is, right? Sloped maybe uphill from right to left. And it says it climbs 120 feet. That is the vertical part. But in order to get that 120 feet, there was a horizontal travel of 4,250 feet. That is here, okay? So 4,250 feet horizontally corresponding to a 120-foot vertical change. Also note that that diagram is wildly out of scale. The bottom part is supposed to be like 40 times the vertical part. It's okay, it doesn't make any difference here. We just wanted like a ballpark sketch. It's fine for it to not be to scale. But let's go ahead and draw the other road over here. So this is going to be B. And we'll just highlight again, the road is the slanted part there. And go ahead and label the 2 numbers for B. Okay, and so we've got these two roads here, and I'm going to ask a couple of questions. Which one has the bigger vertical climb, A or B? A climbs 120 versus B, which only climbs 95. So if we just look at that number, it might feel like, oh, okay, so then A is going to be steeper because it has a larger vertical climb. However, we also need to take into account the horizontal. Which one has a longer horizontal? Also A. And so it isn't obvious, actually, which one is steeper because, yeah, A climbs more at the end of the day, but it also takes longer to get there, okay? All right, so what we are going to do is calculate a ratio, a fraction. So I'm going to call this fraction the steepness of A, and we're going to change that word steepness to a more mathy word in just a minute. So the steepness of A is going to be defined to be this vertical divided by the horizontal. So 120 feet up corresponding to 4,250 feet.
I was trying to keep that.
120 feet up corresponding to 4,250 feet horizontally. Okay?
Yeah.
Yeah, okay. A little bit startled. Okay, and then I typed that into my my calculator and I got about 0.028. It's not exact. Okay, we're going to play the same game over here. It is somewhat arbitrary that I'm choosing to put the vertical on top, but I've got a good reason for doing that. Let's do the same thing over here. Vertical on top, horizontal on the bottom. Fill in the two numbers, please, for road B. So what do we have there? 95 over 2875. So if you have a calculator handy, let's type it. I don't need everybody to do it. 0.033. Yeah, and then it has some other digits, right? Okay, so not exact, but close enough. Okay, so I've got the steepness number is 0.028 for the first one and a steepness number of 0.033 for the second one. And somehow, like, whether one is bigger or smaller is going to dictate which line is steeper. But we just have to think very carefully. I don't want us to guess. Let's think carefully about what these numbers actually represent. This 120 feet was 120 feet vertically, right? And this 4,250 was horizontal feet, yes? And so this 0.028, if I really wanted to force it to look like a fraction, it would be 0.028 over 1, right, if I'm really forcing it to be a fraction. And the units of this fraction have to be the same units that we started with, which was vertical over horizontal. I'm just going to put V and H. Really, it's feet for both of them, right? So what that means for road A is that for every 1 foot horizontal, we go up 0.028 feet vertically, okay? And then the same thing over here, over 1, so vertical on top and a horizontal on the bottom. For every 1 foot horizontal, we go up 0.033 vertically. So now we can compare. Now it's like an apples to apples comparison. In both cases, we're imagining traveling 1 foot horizontally, all right? Got these two roads. They're almost exactly the same steepness. But now they're both going 1 foot horizontally, and they're going slightly different amounts vertically. Which one is the steeper one, the smaller or the bigger? One vote for smaller, one vote for bigger. We need more votes. Which one is steeper, the smaller number or the bigger number? No, I mean the 0.028 versus the 0.033. All right, I think we're all on board with this 0.033. It's the bigger one because they're both traveling 1 foot horizontal. The road A is a 0.028 up, but road B is a little bit more up, so it's got to be steeper. Okay, so here is a complete sentence justifying what we just said. Since the steepness of B, we're including the number here, which is that 0.033, is greater than the steepness of A, again including the number 0.028, road B is steeper. Okay, and I promised that we were going to change the word steepness into something else. What's really the word that we're defining? Is slope, right? I'm not going to call it the steepness, although that's what slope is measuring. But the slope of a line, just like our roads were two lines, is just defined to be this vertical change divided by the horizontal change. So here it is in number 2. To measure the steepness or slope of a, and then there's this parenthetical non-vertical line, we use the ratio that measures the vertical change, that's the y-coordinate, we can think of it as the rise, to the horizontal change in the x-coordinate, and we might call that the run, okay? So the slope is just the vertical change over the horizontal change. That is the definition. All right, shorthand notation that defines slope uses this symbol, which is the capital Greek delta. Just like we have a capital D, this is the Greek alphabet's capital D, and it often in math and science represents a change. And okay, and we use the letter M to stand for slope. So there are a lot of different ways to think about slope. Here are a bunch of them. Slope equals M, that's just a choice. It is the change in the y coordinate over the change in the x coordinate. Kind of regret putting the hyphens there. I don't want you to think subtraction. That's not what those are. Those are just hyphens, y coordinate, x coordinate. But over here, that is subtraction. y2 minus y1 over x2 minus x1. Formula you might have seen in your past. We will use it very soon. Or delta y over delta x. Delta, remember, stands for a change. And after all, if I give you two numbers and I say how much did they change by going from like 2 to 7, you'd have to subtract, right? To get from 2 to 7, there was a change of 5 units, yeah? And then just sort of in English, rise over run. Kate.
Are we just using M for just slope for now, or is it an overall?
We're going to be using the letter M for slope all semester. Yeah. Okay, let's take a look at number 3 here, and I think we'll get partway through this problem, and then we'll pick it up next time. So here we go. In a previous class, we graphed the equation y equals negative 200x plus 800, showing the altitude y of a hot air balloon in feet, x minutes after releasing air from the balloon. Remember this? So time was passing on the horizontal, and this balloon, what is it doing as soon as you start releasing the air? It is falling, right? Initially, 800 feet off the ground. What does this 4 mean? 4 minutes in, it is 0 feet off the ground or on the ground. Okay, but let's see if we can calculate the slope. So it says we're going to choose any 2 points on the line. I'm going to pick these 2 points, 0, 800. Plot them here. 0, 800. And then 3, 200. So that's here. So I picked those 2 points, but there are lots of different points we could pick. And then we're going to calculate slope. So here we go. Slope, again, is M. It's a change in the y over the change in the x. And so let's take a look at the y's. 800 there, 200 at the end. So how much is the change? 600, right? It goes from 800 down to 200. That is a change of 600. So I've got 800 minus 200. Then let's take a look at the x's. There and there. 0 and 3. What is the change? Yeah, is it 3 or is it negative 3? This is one of the few places you can go wrong with slope, is to put the wrong sign. And so all I'm going to say about this, and we'll repeat it next time, is that whatever order you subtract the y's in, you got to subtract the x's in the same order. So because we did 800 minus 200 in that order with the arrow, you got to do 0 minus 3 in that order. As long as you do them both the opposite way, totally fine. Okay, so here's our calculation. 800 minus 200 is 600 on top. 0 minus 3 is negative 3 on the bottom. Altogether, that is a negative 200. Again, what is that called? That is the slope. The slope of that line right there is negative 200. So next time when we pick up, we will talk about what that slope means and what impact it might have if we pick 2 different points. Good work today. We will see you soon. Tuesday. Oh, I didn't check all homework. If you want me to check it now, I can. Otherwise, I'll check yours on Tuesday.